Yes. So we have nine more classes, including today's class. So in today's class, we will talk about strings. Uh, Conceptually speaking, it's so it there is not much there to strings if you already know about pointers, etc., which we already studied. Pointers and arrays we already studied, so it's very easy to grasp the ideas behind how to handle strings in C programming language. In the next class, we will talk about accessing files. So if you have data present in a file, we have seen how to access data in a file using input redirection operation. Uh, but that may not be quite sufficient in many cases. So you would like to use files in a more or access files in a more direct fashion. So that's what we will study in the Wednesday's class. And on Friday class, we will look into dynamic memory allocation and then possibly also take a peek into how to write simple like data structures such as linked lists, etc. That kind of completes more or less all the core conceptual ideas in this course. Uh, and then we have that leaves us with 6 more classes. In those 6 classes, we will primarily focus on solving problems. Maybe we'll solve some few problems related to recursion, few problems on sorting, so few problems on how to deal with external memory algorithms and things like that. So we'll have 6 classes. Maybe one class on memory leaks also I will talk. So that is the rough plan. Uh, yeah, we will see. Okay, so office hours, not everyone. We will see what we can. So on lab 5, I think most probably TS will look into it rather than OJ. So okay, with that we will get started. Uh, so the plan for today, so let's get started here. So we started with this program. So in the maybe in the first class, so at that time it is maybe that pun.c program. Let's look at that program. Yeah, let me copy this code. Great. So this is the program that we started working on. Uh, so the and like when we compile this program and run it, you print that string on the screen. So, but what is the actual parameter that is being passed to the printf function here? So the actually what happens underneath is there is what is called as a string literal or a string constant. So the string that is present here, this is what is called as a string literal, or you can even call it as a string constant. So compiler will create somewhere in the memory, uh, so memory uh, for this string literal, it will be allocated, like t will be present here, followed by that o will be present here, followed by that space will be present here, like that. An array of characters, each character is of length 1 byte. An array of characters will be created, and then let's say here /n is there, and then followed by that what is called as a null character will be present. This is null character is \0. So the bit representation for null character is all zeros. So it's a all zeros, 0, 0, 0, 0, 0, 0, 0. So this is the bit representation for the null character. And then, so of course the memory doesn't end there, so it just keeps going. Okay, so it just keeps going. It's a bad drawing, but you get the picture. So somewhere in the memory, so an array of characters, memory for this whole string will be allocated, and each byte of that array will be assigned or initialized with with the characters that are present in the string, and 0 is the null character is appended to that string. And what happens is to printf, you don't pass this string to the printf. Instead, you pass a pointer to this character array, or the string is what is being passed, what will be passed to the printf. And printf will start printing everything until all the characters onto the screen, until it hits the null character when it knows that the string has come to an end. So this is an important idea in C programming language. Then when we are working with strings, so the understanding is the convention is that string should end with a null character. So when you are using string library, string.h, there are many functions that are available in string.h, and when you use that string library, what happens is the convention is that the strings that you pass to that when you call functions from that string library, there is an implicit assumption that all the strings they end with ampersand, that null character. That's true. If there is a /0, then good question. We are not. That's the point that I'm trying to make, Tanmay. We are not passing uh, characters to printf. We are passing a pointer to an array of characters, and that array of characters, it's a special array of characters when we terminate it with a null string 0. So let me clear. So this is equivalent to what you are seeing here is equivalent to, let's say, let me keep this one here. Yeah, dot C. Okay. So 12.c. So here this is kind of equivalent to this char star str is equivalent to this. There are a bunch of questions. I'll answer your questions. I'll take your questions in a moment. So What you are seeing here in pun.c, and this is internally, this is what happens. So a string literal will be created, and the base address of the string literal, that string literal is an array of characters, and the base address is passed to printf. So shall we compile these two programs and see what happens? And also at this point, I would like you to see, we don't need to open a separate terminal. Many times we can just use the terminal that is present uh, in VS Code. At the beginning of the course, I didn't want to confuse you. So because of that, I was using a separate terminal. And sometimes when the output length is also long, then it is easy to see it uh, on a separate terminal. So that's the reason I was using it. So let's compile this program. So gcc pun.c. So you run the program. So you have this. By using the terminal within VS Code, uh, you can save time. Yeah. Format not string literal. Let's see what happens. Yeah, so the same thing is there. So this is what happens internally. This is what happens internally. What you are seeing in pun2.c is what happens internally. And there is this question: what if we kind of artificially keep a /0 here? Let's see whether this will work or not. So what will be the expected? So what is that warning? Format not string literal and no format arguments. So yeah, maybe const char star. Huh? Okay. So let's execute this program. Yeah. So you can see that it printed to see or not to see till this point space, and then it terminated. After that, the prompt came. No, it is still a string literal, except that the whole thing is a string literal. But when from the printf perspective, printf kind of keeps reading this. And when it hits a null character, it assumes that the string has ended, and it stops there. Yes, the printf parameter is a pointer. That's true. It's a pointer. It's an address. I see a bunch of questions. Trying to see. Varshita, it stops reading. No, we are doing a printf, right, Varshita? So when there is a printf, you print the whole thing. Okay, I think most important question here is Yash's question. See what happens, guys. This is what I tried to mention. For the time being, let's remove this thing. For the time being, let's remove this. We will revisit this again. I want all of you to pay. You can kind of hold on to your questions for a moment. Keep the chat box like that for the time being. If you have questions, let it be like that for some period. And then you can ask questions. The point here is this. When char star str, so what it does, the semantics of this is the compiler creates an array of, uh, it creates a string literal. A string literal is nothing but an array of characters terminated by a null character. So in order to make it slightly more, no, let me use a small string. Let's say this is what we have. So the question that is being asked is, so like how is it possible, no, that hello is being stored in str, where str is a pointer to a character. It's the way I would like you to think about it is, so this is your memory, and the compiler, what it does is, uh, it puts h here, it creates a memory for h, e, l. Okay, so o slash n followed by backslash 0, and then this memory keeps going, and str, it points to this, to the address of the first character. Are you with me on this one? This is what I want you to understand. The semantics of the statement on line 5 is what it is. And when we pass, what we pass to printf is the value that is present in str, that is nothing but the address of the memory location in which the character h is present. What are these codes? Or what it says is, no, the ASCII value associated with h will be present there, and the ASCII value associated with e is present there, and the ASCII value associated with l is present in this memory location, so on and so forth. That's what that code says. No, see, I think you should uh, see, for printf you are using, so there is a difference. You are not understanding this particular thing. This is, so far you have been very naive, no, percent d, let's say 12. Yeah, let's say str percent d. What do you think will be printed in both these cases when we run this code? So gcc punto.c. See, what is happening here is, earlier we are doing this printf, this, and then followed by that whatever the things that we would like to print. This whole format specifier, it is a string. And when we started, no, we don't want to get into all these mechanics. We just took it as it is. But internally what happens is, a string literal will be created. What is a string literal? It is an array of characters followed by a null symbol. And the address of that string literal will be passed as parameter to printf. We already compiled it, Rajashri. So you compile it, it exactly prints, both the printf statements on 6 and 7 are exactly the same. We already compiled it. So I don't know what, see, gcc punt or same, I'm repeating the same thing again and again, that, what is there on line 7, it is equivalent to create a array of characters, create a string literal. What is a string literal? It is an array of characters followed by a null character, and the address of that string is passed as parameter to printf, and this is all being done automatically for you by the compiler here. But internally, that is what is happening. What is happening on line 6 is what is done by the compiler when you use the statement on line 7. Yes, arrays must be pointed. You cannot pass an array uh, as it is. You have to pass the base address. Yeah, of course. This pointer logic can be applied to an integer array also. How many of you are with me? Let me get a sense, because I'm just getting. Just hold on. Because I'm repeating the same stuff again and again, so that's the reason. You cannot pass a string to as it is. You cannot pass an array to a function. You have to pass a base pointer of an array to the function. Okay. You cannot store a string in single quotes. Single quotes means it is it's a character. That is the same as printf. If it has more than 1% d, then you just try it out, then it will just kind of complain as it is compiler itself. There is a question that if had more than 1%, more args than 1 args in the printf. So that's a different point. That's the way a character in double quotes is nothing but a string. A character in double quotes is nothing but a string. Okay, so there is one more question that is this. So if you want to print a string, there is a nice question. So let me. So if you want to print strings, okay, let's see. Let's printf. So let's say let's use this. So if you want to print a string, the format specifier is percentage. Uh, so there is this interesting question. So there are two ways of printing str1. One is using this printf percentage str1, and other is printf str. So here both these things will work, but you may want to use the first option in some other cases. Okay, let's say print. So here if you can see on line 7 and line 8, you are just on line 7, you use %s to print a string, and or you can just use %printf str1. But when do you want to use the %s format specifier? Let's say if you want to combine it with, let's say for example, you want to do this. Then now what you can do is, no one this will be there. So one arrow followed by that string will be printed. So this is the case where the first approach might be useful. Are you with me on this example that you can use percentage to as a format specifier, and but on line 7 you want to print str1 in combination with other things. So one more, yeah. So one more idea is, uh, yeah. So let's before we go there, we can use even puts to display string. Puts str1. We can use puts to display a string. Let's puts, I think, means put a string onto the screen. And so one thing you can see is when you do puts, let me do one thing. So printf str1 versus puts str1. So puts will put a new line character by default at the end of the string. So there is a new line character in our string, and then on the top of it, it puts one more new line character. Because of that, you will see an extra new line in the output. Are you with me on the difference between puts and printf? Puts just adds one more new line character at the end. That's all. So there is one question that is being asked. What is the difference between a character array and no string, string and a string literal? Let me. So what is the difference between? Okay. So this is a nice question. So let's see how this works. So printf str1, and let me do printf str. So you can see that both this line 5 and line 6, they are acting similarly. But what you may want to be careful about is when we do str1 of, let's say, you want to say str1 of 2, that is str1 of 0 is h, str1 of 1 is e, and str1 of 2 is l. That is, so remember, so this is str1 of 0, and this is str1 of 1, and this is str1 of 2. And so similarly, str2 of 0 is h, similarly the same is equal to h. So we use this single quote to indicate that the ASCII character associated with h is assigned to str2 of 0. So now let's see, let's format document. Let's say I want to replace the L with exclamation mark, str. Will this work? Someone is saying it will work. No, because I didn't keep this. Not because of that. So in order to make this into a character, you have to put this code. This is the question that is being asked before. We have to put quotes around it. When we put quotes around it, the ASCII value associated with that code, with that character, will be stored in the corresponding location. So whenever we are referring to characters, no, so there is this question, don't we need to do str1 plus 2? So it's not necessary. So this one automatically gets converted into str1 plus 2. We don't, we can just use str1, one of 2, not a problem. So let's compile this program and see what the compiler says. Is there an error? Yeah, there is not a real an error. Huh. There is a segmentation fault that has come. GCC segmentation fault core dump has come. So let me comment out the first line and see what is happening. Okay. Now if it is, now it is working. Now this hello world is working, and the first str1 we are not modifying, but str2 we are modifying. That L is replaced with exclamation. Star str12 doesn't work, yes, because str2 refers to, so when you do this thing, so Ash has this question which is worth, it's not about this. So this, so when we do star str1 2, this is equivalent to doing star of str1 plus 2. So star of str1 plus 2 is equal to L. So when you try to do star L, where no L is the ASCII value associated, you go and try to dereference that location. That could be 64 or whatever, depending upon the ASCII value of L, and then you get into trouble. So this is where I want to you to pay. Let's see why there is this segmentation fault. Let's uncomment this code and see, try to understand why there is this segmentation fault. So GCC minus G str array dot C gdb a dot out run. So if you see, please pay attention, guys. None of whatever you're saying, it's not quite there. So if you see, the segmentation fault is coming on line 8. That is when we are trying to do this assignment to this, we are getting a problem. Let me do one thing. Clear all my drawings. Let me control D. Let's go back to the terminal. CD strings gdb. Let's compile the code again. gcc str array. Let me use -g. Yeah. So in main, what is happening is in main, when we are doing an assignment to str12, we are getting a segmentation fault. So why is this? Why do you think this is happening? Are you happy with the code? Okay. So let's see. Yeah. Let's try to understand this using but let's see if the assembly code will give us some kind of hint to this. Yeah. So here is the hint, guys. Please pay attention. In the assembly code, you can see that there is a section called as read-only data section. And in that read-only data section, the hello world string is allocated memory. So it is not possible for you to modify the data that is present in the read-only section. So when you go and try to modify it, you get a segmentation fault. No, it doesn't matter, Sushil. How you use it is not the problem. You can use star str1 plus 2 is equal to whatever you want to do, but the problem is all literals, string literals, constants, they will be allocated memory in the read-only data section. But if you see, the memory for array is allocated somewhere internally on the stack. Actually here in this program, the memory for array is allocated on the stack. For str2 is allocated memory on the stack, whereas the memory for this string literal, it is allocated on the read-only data section. So because of that, we cannot modify this. Are you with me here? How many of you are with me? You understood that str2, it is allocated memory. The way this str2 works is, again going back to our idea that every function will have a activation record. So this is the activation record associated with main. So on main, so str no like so hello world. So here with respect to this str2 goes here on the stack, it goes. But whereas this str1, it will not be stored on the stack. It will be stored in a read-only data section. So because of that, you cannot modify it. String literal is very simple. You cannot modify it. That's all. You can only read it. You cannot modify it. But whereas a string, it is possible for you to modify. As simple as that. So Kishore has a good question that why is it not no on line 8? Why is compiler not complaining? No, no, you cannot cast and access it. It's not the thing. Here on line 8, the compiler could possibly have said, you know what, str1 is So Kishore, that could be the reason why it is, why the, please hold on for a moment. So Kishore has a good question that on line 8, why is compiler not catching and giving an error? In order for that compiler, to not, that could be because of the reason, like for example, if I do something like str1 is equal to str2, and then try to modify, uh, and then modify this str2 is equal to, do you think this will work? This is a good, no, yes, this is a fun thing. I see lots of no's. Who is going to go yes? Yeah, so let's see what is happening. Remember, I am commenting out line 10 and I'm saying str2 is equal to str1 and str12 is equal to this, and then let's see what happens. See, it's working. The reason is, uh, you have to get a good understanding of pointers. So let's say str2 contains some address. str2 contains the address of, it contains the base address of an array. So not the base address of an array, yeah, the base address of the array of characters. That base address is being copied to str1. And now str1 and str2 both are pointing to the same memory location. So that's it. That's true. str2, this statement makes str1 point to the hello world string, which is present on the stack. That's true. Pratyaksh has the good observation that str1 is not read only, but what str1 is pointing to on line 5 is read only. And why did we do this? So because Kishore is asked the question on line 9, the compiler should have caught earlier. If this is the case, like there is this thing, the compiler should have given an error saying, you know what, you are trying to modify a constant memory. Why are you not doing it? The compiler could have done it, but the compiler didn't do it because something like this is possible. So because of that, the compiler is kind of pessimistic or optimistic and let the programmer have this way. That's true. Both str1 and str2 are pointers for that string. And now there is one more thing that is being suggested. So that is str2 is equal to str1. Do you think this will work? This will not work because we are never allowed to modify str2. It's what is called as a constant. It holds a constant address. You can never modify str2. Because of that, you can see that no, there is a red underline. Expression must be a modifiable value. We cannot do that. So there are many ideas that we have seen within these very small examples. You can never see str2 holds the base address. You can never modify the base address that str2. It is what is called as a constant. You cannot modify it. str2 is not modifiable, but for a different reason. That is, str2 is an array name. Array names cannot be modified. str2 is a read-only pointer, exactly. I can see brilliant confusion cooking up from the chat box. How many of you are with me completely so far? You're all. We are doing small things, but very okay. So let me kind of take a step back and summarize the discussion again one more time, and then we will move forward. Uh, so let's do one thing. Yeah, let's make it simple here. What is the first idea? The first idea is uh, printf. This is where we started with. So printf takes the format specifier that we have been using in printf all the time when we are using, whatever we have, all these fancy format specifiers, whatever format specifier we have, %x followed by, whatever var1, var2, no? So this is, if you see line 8, for what is the standard syntax for printf? You start with a format specifier, which is a string, followed by a bunch of variables, which kind of no, which you would like to print as a part of the output. So, the first question for you is, maybe I think all I want the discussion to hold, no, to hold for some time on the chat box, and then again you can start discussing. What are the three parameters that will be passed to the printf function? Can you tell me the type of the three parameters that are being passed to the printf function? Let's say it is int var1 is equal to 2. Yeah, float var2 is equal to 3.0. Let's say %f. So now can you tell me what all the parameters that are being passed, type of the parameters being passed to 10? Why is this an error? There is no parameter type called as string literal, guys. Okay, there is no parameter type called as string literal. So what Aaron mentioned just now, that's the thing that will be the parameter types for this is a char star parameter, pointer to, and this is a, this is int, and so this is float. Are you with me here? That char star, int, and float. Are you fine with this? This is the first observation. And as far as uh, so let's do one more thing. Those of you who are a bit lost, I'm going to recap everything now. So just pay attention and see what is going on. What I want you to pay attention is what is the first parameter that is being passed on line 11 and line 13? What is the type of the first parameter? Both are char stars. Both are char stars. So this is the observation that I would like you to make. Don't worry about constant char star or all those things. Okay, that's true. The pointer holds the address of H. That's true. So here, since we are here, I just also want to kind of make one small thing that I can say hash define format. Let's say there are two kinds of formats that are possible. You can kind of say, if, yeah, let's not waste our time here. We'll look into it later. So in both the cases, we are passing char star. But one thing what we want to understand is this is not allowed. Okay. str1 of let's say 3 is equal to some character, whatever, L. This is not allowed. Why is this not allowed? Because the memory for this hello world, this string is allocated in the read-only data, and when we try to modify it, we get a we get segmentation fault. So this gets translated into star str1 plus 3 is equal to L. From the compiler, and then, sorry. And if you see str2 of 3 is equal to L, so both of these things, they will be the same. Yeah. So this is str1 and this is star str2 plus 3 is equal to L. Whereas this will be successful, this will not be successful because the memory for this is allocated in the read-only. Are you with me on this one? 15 and 16. Do you see? I'm just recapping what we discussed in the class so far. So this is a difference between just a string and a string literal. Great. Yeah, I think pretty much that is what it is. So these are the two main ideas that we have seen. The difference between a string literal and a string. And no, when we are passing something, for printf, when we are passing this format string, you are passing a pointer to a it's character pointer. That character pointer could be to a string literal, or it could just be a string. Yeah, there is one more idea which the third idea is this. Okay, so the third idea is now forget about so the third idea is when we do str2 is never modifiable. Whatever that is there on the here, it doesn't matter. On line 18, str2, the not because of a string, any array, if you say int a something, any array variable, it cannot be modified. It's set to a value and it cannot be modified. Like for example, here, let's say int A of 10. So like for example, if you would like to put A here, whatever independent of what is present on the right hand side, we cannot modify what is there on the left hand side, because let's say, let me put it this way. Okay, so now you can see that on line 20 we are not able to modify A, because the names of an array variables, they cannot be modified. Are you with me on this one? Let's take one question. You should try to follow my line of thinking. Otherwise, it all gets mixed up. What I'm trying to point out here in relation to arrays is the array variable, it can never be modified. Like for example, on line 8, we have declared int a of 10, and if we say a is equal to something, it's not possible. You cannot modify it. The name of an array is its base address, and you cannot never modify the name of an array. A variable, you can never modify an array variable. Are you all with me on this one? What I am showing on line 19 and line 20, are you with me? Let's take one thing at a time. Otherwise, we will never. Okay. So now, after this, the next point that I would like to point is this. That is, str1 is equal to str2. At the beginning of the program, str1 is pointing to a hello world string, which is present in the read-only data section. But at this point, when we said str1 is equal to, sorry, when we said str2 is equal, str1 is equal to str2. Yeah. So this one, these two things, leave it. On line 22, when we say str1 is equal to str2, so what happens is before line 22, str1 is pointing to a hello world string, which is present in the read-only data section. And after line 22, str1 is pointing to a hello world string, which is present on the stack, because str2 is an array which is allocated memory on the stack. Does it make sense, line 22? Are you with me here? Line 22. That's all. These are the important ideas. Now str1 and str2, they are pointing to the same memory location. And whether you access str1 or str2, it's the same. So str1 and str2 are aliases of each other. So now let's try to do a GDB and see what happens. GCC minus G str array.c GDB a.out enable. So line 5 got executed. After line 5 got executed, let's say I will use printf print/x str1. So what is present in str1? Can you just make a note of what is present in str1? str1 is, it has some address. Okay. So now let's do print/x str2. Let me use a different print str2. How do I print? Here GDB is being bit clever, and I want to see how to print the address that is present in str2. Yeah, let me do one thing. Print/x. We have to come around the smartness of GDB. Yeah. Thank you, Kishore. So yeah. So here I want you to make a note. The address of str, whatever that is present in str1, this is the address of this hello world string, and this is the address of the hello world string that is present here, and in hexadecimal form. And then next, and next, and so yeah, let's keep going. Control L. I didn't uncomment it. Okay, sorry. Let me remove all this code. No? So let's make it very simple. because I want to focus on just one thing. Yeah, let's do this. GCC, or maybe let's see if I can run it in. Oh, I thought I set it up. Okay. Okay, great. So now let's see. Let's try to put a breakpoint here. Let's terminal toggle breakpoint. Start debugging. Yeah. Okay. So now let's see str1. Whatever that is present in str1 is this. Let's see. And so if you want to see the address of print/x address of str0, okay, let's try to do it on the terminal guys. Okay, maybe it's easy to do it here. gdb a.out. Okay, let's pay attention here. Let's the last 5 minutes. If we are, let's come back. So stop debugging. This is the code that we have. So all I want you to show is print str1. Let's compile this code. So can you take a look at this code and see if you're all with me on this code? Can we take a look at this code? Can you all take a look at this code? That str1 is, it started by pointing to a string literal. On line number 8, we are changing it to point to what str2 is pointing to, and then we are modifying using this particular statement on line 10, and then we are printing it. Okay, gcc str array.c. Let me use. So can you make a note of what is address present in str1? And then, so you can see print str2 0. Let's see what is present in. Yeah. Something weird is happening. str1 is equal to str2. Yeah, it is different. Huh? Huh. Yeah, now it is, now str1 is pointing to this, but in between. Okay, so but anyway, at this point, so I think there is a bit of confusion here. In between, str1 is pointing to something. This part I didn't understand what is happening here. Any idea on what is happening here? On here, it's of course after this assignment statement, both are the same. Something weird happened there. But what I want to show is this, that after when we do str1 is equal to str2, the base address of str2, this address, this is being written to str1, and we are able to modify this address. Okay, let's run it again. Run. Okay, you help me out here. So is this the... I think I understood the problem. I think I understood the problem. Yeah. We made a small mistake there. Yeah. The first value that we have printed there is garbage. Okay. So now we have to execute the line. Okay, let's reset now. I got confused and printed the contents of str1 at the wrong place. We are about to execute line 5. Okay, so we do next. Let's do a print /x str1. Are you with me here till this point? Okay, so those of you who are a bit confused, this is the time to sync up. And then next, let's do next. And then let's see what is there. Printf /x str2 0. Again, are you with me here on so far? str1 and str2, they are pointing to two different memory locations. So if this is here, so there are two hello worlds present here. Initially, str1 is pointing to this. This is RO data section, and this is stack. This is str1, and this is str2. This is the picture so far. This is the picture so far. So we want to print it in hexadecimal format. That's the reason. So now after we execute this, what happens is now this is pointing to this. So now let's print /x str1. Yeah. So now you can see that the address of base address of no, str2 array and str1, they are pointing to the same. Are you all with me here? And then when we do a next, so what happens is this gets translated to star of str1 plus 2 is equal to this. But no, but str1 is now pointing here. So the hello world string that is present in the stack gets modified. It didn't work last time because I printed str1 before line 5 got executed. So because of that, it didn't work. You understood the problem before? We did a mess. Having a 2e enable helped us to catch this. And then next, great. So print str1. You can see when we do just print str1, the string got changed like this. Are you with me here? Are you all with me here? And let's say if you say str4 is equal to X. How do we do this? Set str1 4 equal to 0. Does this work? Print str. Yeah. So do you see now what happened when we tried to print str1? Because since we made str1 of 4 equal to null, we stopped it there. You understood the whole exercise, what we did in this last session, last 10 minutes? Are you all with me? If you understood the last 10 minutes, it's the core of the today's lecture. Set is just like from GDB, how you can set a memory location. That's all ish. So set is a command, GDB command to go and modify a memory location. So that's what we are. This won't affect the real code. That's true. We are just playing with GDB and messing up with stuff here. Can we write str2 is equal to str1? It is not possible because str2 is a constant. It is an array variable. It cannot be modified. No, no, no. You got the moral of the story wrong, Lakshman. It's not like that. Array variables are, no. String literals are not modifiable. That's all. The moral of the story. So if you're all doing great, so shall we take a break for today or? That is the language semantics. You don't want to, the language says the array variable cannot be modified. It's a constant, it cannot be modified, Sushil. The question is why str2 is not modifiable, because the language says a array variable, it cannot be modified. No, pointer arrays are not at all like any, like for example, in this code, it's not necessary on line 5 to initialize, no, to do this initialization. It's not at all necessary. Let's do one thing. So you know what? So like for example, this is perfectly fine. So there is nothing wrong in this code at all. When we do printf some string, is there a way to get back the address of the string literal? Not possible, Pramod. It's not possible. Unless you go to assembly code and kind of do something. So wait, what do you mean by all the access of first? No, Vivek, that's not true. What you said is not true. A is a constant and you cannot, the base address, an array variable which holds the base address of the whole array, it cannot be modified. That is the rules of the language. I think we should take a break today. I want you guys to go through this lecture one more time and think about it carefully and come back in the next class and ask questions. I think that's the right way because but otherwise, if you have some questions, you can hang around and ask. But my suggestion is we'll stop here. Think about what we discussed in today's lecture. You come back to the next class and you can ask me questions.